Alright, this is your second part of your 2.4 notes. Next we're going to talk about the division algorithm. So what this is basically a way to rewrite a function. So if we want to take this is our function right here, 6x to the fourth plus 5x cubed. We want to take this function right here. That's our f of x. Alright, and we want to write that as the divisor, right, which is this 3x squared minus 2x, times the quotient we get when we do the long division, plus any remainder that we get when we do the long division. So let me show you what we're doing with some numbers, just so you can understand it. So let's take 11 and divide it by 5. Alright, in this case 11 is our dividend, 5 is our divisor. So 5 goes into 11 two times, right? 5 times 2 is 10, subtract, I get a 1, this is the remainder. So what we're saying with this process is 11, the dividend, is equal to divisor 5 times the quotient is the number on the top here, 2, plus the remainder, 1. Right, you see that works fine. 5 times 2 is 10, plus 1 is 11. So that's what we're doing. We're just doing the division out, and instead of writing that remainder over the divisor to get a mixed number, instead we're rewriting a function in a different way. Okay, but it's perfectly valid. Again, the parallels to regular numbers don't really ever stop with polynomials. I mean, they basically behave almost identically to numbers. Alright, so let's get this division done so we can get the quotient and the remainder. Alright, notice when I wrote out my dividend, it skips over from cubes, degree 3 to first degree, and I account for that with the 0x squared. I need a place value for everything in there. Okay, it's no different than, you know, a number like this. We put a 0 in there as a placeholder because 1052 is not the same thing as 152, so we need that 0 placeholder. We need the same thing for polynomials. If there's no x squared term, we still need to account for it when we do our long division. Alright, 3x squared minus 2x. Alright, and I'm going to write a plus 0 because same concept. We want a placeholder for every possible number. Alright, so start the process. X squared, x to the fourth. So we're going to start it over that place value that I added in the problem. So 3 times 2 is 6, so I need a 2 right there. And then x squared times x squared is x to the fourth. So 2x squared is what I need to multiply. Here I'm going to get 6x to the fourth. 2 times negative 2 is negative 4x cubed. And then 2 times 0 is 0, x squared. Alright, subtract, and you can change your signs. So this goes away, I end up with a 1x cubed or just x cubed. A 0x squared, doesn't matter if you write plus or minus really. And then bring down your 3x. Alright, now what do I need to multiply 3x squared by to get 1x cubed? Well, I need to multiply the x squared by x, but to get from 3 to 1, I need to multiply by 1/3. So we need to multiply by 1/3 x here. Alright, 1/3 times 3 is 1, and then x times x is x cubed. Alright, 1/3 x times negative 2 is negative 2/3 x squared. Alright, and then 1/3 x times 0 is 0x. Alright, subtract, change your signs. So this is going to be 0, this is a 2/3 x squared. Alright, then 3x minus 0x is 3x. And then bring down your minus 5. Alright, again, we're dividing now down here. What do I multiply 3 by to get 2/3? Well, if you need help with that, just write it over here. 3 times something gives me 2/3. To find out what the something is, divide both sides by 3. So a equals 2/3 divided by 3. Remember, 3 is the same thing as 3 over 1. So I can write that as 2/3 divided by 3 over 1 is the same thing as times 1 over 3. So A is 2 times 1 is 2, 3 times 3 is 9. So I need to multiply by positive 2/9. Alright, 2/9 times 3x squared is 2/3 x squared. Alright, and then 2/9 times negative 2x is negative 4/9 x. Alright, and then 2/9 times 0 is 0. Change your signs. Alright, this is 0. 3 plus 4/9. If you have a calculator that can handle fractions, use it. If not, you just have to get common denominator. So 31/9 x, and then subtract. Bring down your 5. Alright, so there is our remainder. So we got the rest of what we need now. There's the quotient, plus there's the remainder on the very bottom. So we're ready to go. We're ready to write this using the division algorithm. Alright, so 6x to the 4th plus the 5x cubed plus 3x minus 5 is equal to what we just got here, the 3x squared minus 2x that we divided by, times the 2x squared plus 1/3 x plus 2/9 that we got as our quotient, and then we add to it the 31/9 x minus 5. Okay, that piece is our remainder. Alright, so the dividend is equal to the divisor times the quotient plus the remainder. That's the division algorithm. Alright, but this example is also to show you a couple other new things. One, the zeros that you have to use to fill in, if they don't show up in the dividend or the divisor. Okay, likewise, if this had missed the x term, if we divided by 3x squared plus 2, we skip over the x, we would still need a 0 there, just like we needed for the constant. Alright, and then also to show you it doesn't have to be whole numbers everywhere. We can have fractions, and these we're responsible to be able to figure out what we need to multiply a number by to get anything. Okay, fraction, decimal, whole number, positive or negative. You need to be able to do that basic math to the arithmetic required to get these coefficients, whether they're fractions or not. Alright, synthetic division. Synthetic division is a process to divide a polynomial, but it's typically only done if you're dividing by a line. Now, you can do it if you're dividing by a cubic or a quadratic or something, as long as that thing were factorable, and you could factor it and get it down to linear factors, and then you would have to do several different steps of synthetic division, but it's mainly done when your divisor is a line, like mx plus b. So when you do a synthetic division, whatever your divisor is in the long division form, the thing that you put in this little box for synthetic division is the things that would make the divisor equal to 0. So x minus 3, positive 3 would make that 0, so we put a positive 3 there. Alright, and then the coefficients of the original dividend, in this case were 1, 4, negative 5, 5. You see 1, 4, negative 5, 5 there. Now what we typically do, what you'll see in the upcoming examples, is we skip a line, and then this number is brought down, and then it's multiplication. 3 times 1 is 3. This is addition, 7. 3 times 7 is 21. Addition, 16. 3 times 16 is 48. Addition, the remainder is 53. So the important things are, when you do synthetic division, these right here are your coefficients of your quotient. 1, 7, 16. 1, 7, 16. And this last number, whatever the very last column is always the remainder. Okay. But the nice thing about it is you don't have this filler in between, the subtract, the bring down, the repeated division. It's just multiplication and addition that arise at the quotient and the remainder. So synthetic division, again, the key things are this has to be a line, so a linear factor. Alright, and this number in the box is what makes the divisor equal to 0. Alright, so let's practice it so you can see how it's done. Alright, so these are the steps over here. The best thing is just to kind of follow along with the example and just practice it. But in the box goes what makes the divisor equal to 0, so -2 makes this divisor equal to 0. And then out beside that box are the coefficients of this. And remember that if you skip over something, just like with long division, you need to account for it. So we skip over x squared. I'm going to put a 0 in there to account for it. Alright, and then there's a 6, and then there's an 8. Alright, and then I'm going to draw a line right here. The very first thing we always do is bring down the first value. So we're going to bring down the 5. Okay? So that's what it's saying right here. Now we multiply -2 times 5, just like they did here. -2 times 5 is -10. I write that below the next number. Alright, and then what do? We add the next two numbers. So I add 0 and -10. I get -10. Okay? Same thing, I multiply now by the next number that I just brought down. So 3 times 7. And in that problem was 21. Here it's -2 times 10. Or -10 is positive 20. Alright, -2 times 10 is positive 20. Add here, I get 26. Okay, and then finally multiply the last ones here. -2 times positive 26 is -52. Alright, and then this would be my remainder. 8 plus -52 is -48. Now, how do you get your quotient and remainder? You have to remember this was x cubed, this was x squared, this was x, this was your constant. Now everything goes down a power. So this is now x to the second, this is x to the first, or just x. This is your constant, and now this is your remainder. Alright, it'll always be that way, that these powers go down by 1 each time. So this is 5x squared minus 10x plus 26. Alright, you don't have to put the c there. And then because it's negative, we write minus, and then the 48 is your remainder, and you put it over your divisor, okay, which was x plus 2. Remember, just change this sign back and put it behind x. There's our answer.